Hello everybody, and welcome to my presentation for my final project for Robotics-211. So for my project, I kind of went simple. I took the idea of using interrupts and some LED lights and kind of incorporated two buttons. We have one button on interrupt 1 or interrupt 0. We have another button on interrupt 1. When you press one of the buttons, the lights will go from red to yellow to green to blue. And when you press the other one, they'll go from blue to green to yellow to red. So in other words, when you press the left button, the lights are going to cycle forward. If you press the right button, the lights are going to cycle backwards. The code is pretty simple. I wanted to keep it simple because this is my first, project basically on my own with using Microchip Studio and programming in AVR chip using C. It's quite different than it would be programming something else or using Arduino. I actually find I like this a lot better. It runs faster, and once you know what you're doing, it's actually a lot more efficient. So let's get into the code. We'll jump right into it. The first thing I do is I define the CPU to be 16 megahertz, and that's right here on the screen. I include a couple of header files. The AVR IO is the input-output header file. I pretty much use that, in every program that I write. The utility delay header file allows me to use delays. I was experimenting with button debouncing in this because it's a little jumpy here and there, but I wasn't able to get it perfected. I don't know if it's because of the interrupts or not, but you'll see what I'm talking about. And then I use the AVR interrupt code, or the interrupt header, to be able to use the interrupts. We use a volatile unsigned integer, 8-bit integer, that will set the first LED light. And then here's what we do. I've got two interrupts, one running on interrupt 0, one running on interrupt 1. If we trigger the interrupt 0, then the lights are going to jump forward. If we trigger interrupt 1, the lights are going to jump backwards. How this is working is it's working on the falling edge of the interrupt. So basically, when the interrupt senses a voltage change from high to low, it's going to interrupt and then execute the code that's in the interrupt. Now here's the thing. So I'm using internal pull-up resistors for the buttons. That way the buttons are going to remain in a high state or an on state until the buttons are pressed. Then they're going to drop down to 0. That's why I'm using a falling edge on the interrupts, because it makes sense, I guess. So anyway, here we go. Oh boy, main code right here, main program. I set a data direction register D, and I'm actually my first attempt at using hexadecimal code, and it worked. I had to look a lot of this stuff up. I'm not familiar with hexadecimal. I'm learning it, but let's just say by the time I'm ready for employment, I will be a master at this because I'm really getting into this hexadecimal code. So what this does is it sets the register, the D register. And what we do is I set the most significant bit on back, the first 4 of them, so 7, 6, 5, and 4. I set those to outputs. That's what that means. And then 3 and 2 we set as inputs because those are going to be where the buttons are at, and those registers just so happen to be the registers for the interrupts. And then I set 0 and 1 as inputs, or outputs, I'm sorry. So then I do an OR equals on the DDRB, and we set bits 2 through 7 as outputs and inputs. So basically what happens here is we set it, we clear the bits for bits 2 and 3 on the interrupts with this DDR, the AND DDR, okay? So we clear the 2 bits, bits 2 and 3, we make sure that they're clear because we want them clear, so when we use them as interrupts, they're not going to be flagged as something else. Then when we OR it, we're basically telling the computer that, you know, access an OR gate. Now, an OR gate is if one or the other is true, or if both are true, then the OR gate will turn on. So in other words, if you have two zeros, the OR gate is going to be in the off position. If you have 0 and 1, the OR gate is going to be on the on position. If you have 1 and 0, the OR gate is going to be on the on position. If you have 1 and 1, the OR gate is going to be on the on position. So logically, we're telling the microcontroller that we're going to be setting bits 2 through 7 as outputs and inputs, and here's how we're going to do it. You know, we're going to set the least significant bit all the way up to 0, 1, 2, all the way up to register 3. Some people call it register 4, but register 3 as inputs. And then we're going to do the rest of the registers as outputs. So that's how that works. Then I set those pins on port D. I set the 2 bits for 2 and 3 as internal pull-up resistors, because if we set those to 1 and their inputs, if the DDR on those pins are inputs, and we set the port D pins to outputs, it's going to set an internal pull-up resistor for those. And we want those because we want those buttons to remain in a high state until they're pressed. Does that make sense? I hope so, because that's what we do. Okay, so then I use the EICRA, and what I do here is ISC10 and ISC00. That's going to set the interrupts to the falling edge on these interrupts. We're basically telling the microcontroller to say, okay, on pin 2 and pin 3, we want to set these to sense when the voltage is dropping. That's what that does. Now the EIMSK stands for the external interrupt mask, and we enable the interrupts right here. So that's how we do that. Okay? So, oh, actually, that is a mistake. There you go. Okay. The SCI function here is actually a macro, and it basically starts the interrupts. So that's the go button for the interrupts. Now, the while loop is really simple. So we port D, we AND it, so that basically when you AND something, you treat it as an AND gate, and AND is going to be on if 1 and 0 is on, right? Or 1 and 1 is on. They both have to be true in order for that to work. So if you have a 0 in anything, it's not going to work. So we do that to clear the 4 upper bits, okay? And then we port D it, and we OR with the counter volatile integer, and that will allow those 4 bits, so pins 7, 6, 5, and 4, to be able to cycle through those lights. And that's it. That's pretty much the code. It's pretty easy, actually, if you think about it. Explaining it's one thing, running through it's a different thing. So it compiled, no errors whatsoever, and I'm going to show you the schematic. Here's the schematic right here. So this is your AVR chip. We're using a 18 mega 328p. This is your 5 volt going into your power source. This is your ground right here. So we have pins 2 and 3 right here, and those are going to those buttons. Those buttons are going to go directly to ground, and then when you press them, they ground out basically to 0, and that's what starts the interrupt. The rest of these pins here, they go to the LEDs, which go to resistors, so we don't blow them out, and goes back to ground. Very simple, very, very simple. Here's a picture of it, all set up. I'm actually using the Arduino because I wanted to use that as basically the uploader for it. I do have a USB one. Boy, this was a lot faster, so I did it this way. And now I'm going to show you a video with it in action. So I hope that that you guys enjoyed this presentation. I hope you learned something from it today. And if you like what you see, give me an A, because I could sure use it. And have a wonderful rest of the day. Thank you. Hey guys, okay, here is my finished circuit. As you can see, the red light is on. It's going to be a little bit blown out. The lighting in here isn't the greatest, but I'll be able to demonstrate this for you. So I got two switches, two buttons, I should say, and they're both on interrupts. I got one on interrupt 0, one on interrupt 1. And when you push them, if you push interrupt 0, the lights are going to go up or to the right. And if you push interrupt 1, the lights are going to go down or towards the left. So I'm going to push interrupt 1, and as you can see, it works. It jumps a little bit. I still have to deal with some issues with debouncing. It's kind of hard. It's a little harder for me to debounce these buttons when I'm using interrupts for some reason. But don't worry, I'll get to the bottom of it. I just wanted to make sure you guys seen that this is working, and I will continue to improve on it. But I think it's good enough for the grade here. And if you hit interrupt 1, obviously it's going to go down. So there you go. So it's working. It might be, this button might be a little sensitive. You know, these buttons, they're not the most expensive buttons in the world. So that actually might be what's going on. You know, so maybe a little bit of debounce in there. But it's working. I will put some debounce in there though. Now that I'm looking at it, that's exactly what it is. So I can troubleshoot it and get it done. But anyway, this is my final project. As you can see, it's working. It's working pretty good. You know, maybe a little bit of debounce, but that's okay. I'll get it done. Anyway, thank you guys for the time to be able to present my project to you. And I hope you guys have a wonderful day. I really enjoyed this class. Thank you very much. Bye-bye.